हेलो बच्चों, इस एपिसोड ਵਿੱਚ ਤੁਸੀਂ sum of first n natural numbers and its applications ਅਤੇ sum of squares of first n natural numbers and its applications ਬਾਰੇ ਪੜੋਗੇ। ਆਓ ਹੁਣ ਸ਼ੁਰੂ ਕਰੀਏ। Sum of first n natural numbers. If we have only one natural number, that is 1, then sum of natural number 1, that is s, is equal to 1. If we have two natural numbers, that is 1 and 2, then sum of natural numbers 1 and 2 is s is equal to 1 plus 2, which is equal to 3. If we have three natural numbers, that is 1, 2 and 3, then sum of natural numbers 1, 2 and 3 is s is equal to 1 plus 2 plus 3. If we have one more natural number, that is other than 1, 2 and 3, then sum of these natural numbers s is equal to 1 plus 2 plus 3 plus the next natural number. If we have two more natural numbers that are other than 1, 2 and 3, then sum of these natural numbers, that is s is equal to 1 plus 2 plus 3 plus 2 next natural numbers. If we have 1, 2, 3 and so on up to n natural numbers, that is 1, 2, 3 and so on up to n, then sum of these natural numbers, that is s is equal to 1 plus 2 plus 3 plus so on up to plus n. If we look here carefully, then in the sum of n natural numbers, that is s, number 1 appears n times. In the similar way, in the sum of n natural numbers, that is s, number 2 appears n minus 1 times. Also, in the sum of n natural numbers, that is s, number 3 appears n minus 2 times. In the similar manner, in the sum of n natural numbers, that is s, numbers after 3 appear in the decreasing order of n minus 2. In the similar way, natural numbers after 3 appear in the decreasing order of n minus 2. Now, in the sum of n natural numbers, that is s, number n appears only once. Therefore, sum of n natural numbers, that is s, which is equal to 1 plus 2 plus 3 plus and so on up to plus n, will be equal to n plus n minus 1 plus n minus 2 plus and so on up to plus 1. Now, on adding these two equations, left hand side will be equal to 2 into s. Adding the corresponding terms on the right hand side, we will get, adding n and 1, we get n plus 1. In the similar way, on adding next two terms, 2 and n minus 1, we get n plus 1. On adding next terms, 3 and n minus 2, we get n plus 1. Proceeding in the similar manner, on adding next terms, we will get n plus 1. Therefore, 2 into s will be equal to n plus 1 plus n plus 1 plus n plus 1 and so on up to n times. 2 into s is equal to n plus 1 plus n plus 1 plus n plus 1 and so on up to n times. For one natural number, 2 into s is equal to 1 into n plus 1. For two natural numbers, 2 into s is equal to 2 into n plus 1. For three natural numbers, 2 into s is equal to 3 into n plus 1. For natural numbers next to 3, 2 into s is equal to number into n plus 1. For all natural numbers next to it, 2 into s will be equal to number into n plus 1. That is, for n natural numbers, 2 into s will be equal to number n into n plus 1. Sum of first n natural numbers is equal to n into n plus 1 whole divided by 2. The sum of squares of first n natural numbers. Let Sn or summation n square denotes the sum of squares of first n natural numbers. Then Sn is equal to 1 square plus 2 square plus 3 square plus so on up to n square. Consider the identity x raised to the power 3 minus x minus 1 whole raised to the power 3. Using identities, we get the identity x raised to the power 3 minus x minus 1 whole raised to the power 3 is equal to 3 into x square minus 3 into x plus 1. Let this be equation number 1. Putting x is equal to 1, 2, 3 and so on up to n in equation number 1, we get 1 raised to the power 3 minus 0 raised to the power 3 is equal to 3 into 1 square minus 3 into 1 plus 1. 2 raised to the power 3 minus 1 raised to the power 3 is equal to 3 into 2 square minus 3 into 2 plus 1. 3 raised to the power 3 minus 2 raised to the power 3 is equal to 3 into 3 square minus 3 into 3 plus 1. Proceeding in the similar manner, we get n raised to the power 3 minus n minus 1 whole raised to the power 3 is equal to 3 into n square minus 3 into n plus 1. Adding column wise, we get n raised to the power 3 minus 0 raised to the power 3 is equal to 3 whole multiplied by 1 square plus 2 square plus 3 square and so on up to n square minus 3 whole multiplied by 1 plus 2 plus 3 and so on up to n plus n. It implies that n raised to the power 3 is equal to 3 into summation n square minus 3 into summation n plus n, which implies summation n square is equal to 1 upon 3 whole multiplied by n raised to the power 3 plus 3 into summation n minus n, which is equal to 1 upon 3 whole multiplied by n raised to the power 3 plus 3 into n plus 1 whole divided by 2 minus n, which is further equal to n upon 6 whole multiplied by 2 into n square plus 3 into n plus 3 minus 2, which is equal to n upon 6 whole multiplied by 2 into n square plus 3 into n plus 1, which is equal to n into n plus 1 into 2n plus 1 whole divided by 6. Therefore, summation of n square is equal to n into n plus 1 into 2n plus 1 whole divided by 6. ਹੁਣ ਤੱਕ ਤੁਸੀਂ sum of first n natural numbers and its applications ਅਤੇ sum of squares of first n natural numbers and its applications ਬਾਰੇ ਪੜਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਹਨਾਂ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ। Let us see an example. Find the sum of the series 2 into 5 plus 5 into 8 plus 8 into 11 plus so on up to n terms ਭਾਵ ਦਿੱਤੀ ਸੀਰੀਜ਼ ਦਾ ਸਮ ਪਤਾ ਕਰੋ। ਦਿੱਤੀ ਸੀਰੀਜ਼ ਹੈ 2 into 5 plus 5 into 8 plus 8 into 11 plus so on up to n terms. Now let us see its solution. Here the given series is 2 into 5 plus 5 into 8 plus 8 into 11 plus so on up to n terms. Now this series is formed by multiplying the corresponding terms of the sequences 2, 5, 8 and so on, and 5, 8, 11 and so on, both of which are APs. Now, as we know that nth term of an AP is equal to A plus n minus 1 into D, where A is the first term of an AP and D is the common difference. N is the total number of terms in an AP. Now we take the first sequence, that is 2, 5, 8 and so on. This sequence is an AP. So the nth term of this first sequence is equal to 2 plus n minus 1 into 3, because here first term, that is A, is equal to 2 and the common difference D is equal to 5 minus 2, which is equal to 3. So the nth term of the first sequence is further equal to 2 plus 3 into n minus 3, which is equal to 3 into n minus 1. Now we take the second sequence, which is 5, 8, 11 and so on. This sequence is also an AP. So the nth term of the second sequence is equal to 5 plus n minus 1 into 3, because here first term, that is A, is equal to 5 and common difference D is equal to 8 minus 5, which is equal to 3. So nth term of the second sequence is further equal to 5 plus 3 into n minus 3, which is equal to 3 into n plus 2. Therefore, nth term of the given series, that is an, is equal to nth term of the first sequence into nth term of the second sequence, which is equal to 3 into n minus 1 into 3 into n plus 2. This is further equal to 3 into n whole multiplied by 3 into n plus 2 minus 1 whole multiplied by 3 into n plus 2, which is equal to 9 into n square plus 6 into n minus 3 into n minus 2, which is equal to 9 into n square plus 3 into n minus 2. So, the nth term of the given series, that is an, is equal to 9 into n square plus 3 into n minus 2. Thus, the required sum of the given series, that is Sn, which is equal to summation an, will be equal to summation of 9 into n square plus 3 into n minus 2, which is equal to summation of 9 into n square plus summation of 3 into n minus 2 into summation 1. This is equal to 9 into summation of n square plus 3 into summation n minus 2 into n. Now, because we know that summation n square is equal to n into n plus 1 into 2n plus 1 whole divided by 6, and summation n is equal to n into n plus 1 whole divided by 2. Therefore, required sum of the given series Sn is equal to 9 whole multiplied by n into n plus 1 into 2n plus 1 whole divided by 6 plus 3 whole multiplied by n into n plus 1 whole divided by 2 minus 2 into n. On solving it and taking n common, we get Sn is equal to n whole multiplied by 3 into n plus 1 into 2n plus 1 whole divided by 2 plus 3 into n plus 1 whole divided by 2 minus 2. On taking out 2 as the LCM, Sn is further equal to n whole multiplied by 3 into n plus 1 into 2n plus 1 plus 3 into n plus 1 minus 4 whole divided by 2. This is further equal to n whole multiplied by 3 whole multiplied by n into 2n plus 1 plus 1 into 2n plus 1 plus 3 into n plus 3 minus 4 whole divided by 2. This is further equal to n whole multiplied by 3 whole multiplied by 2 into n square plus n plus 2 into n plus 1 plus 3 into n minus 1 whole divided by 2, which is equal to n whole multiplied by 3 whole multiplied by 2 into n square plus 3 into n plus 1 plus 3 into n minus 1 whole divided by 2. So, the sum of the given series, that is Sn, is further equal to n whole multiplied by 3 whole multiplied by 2 into n square plus 3 into n plus 1 plus 3 into n minus 1 whole divided by 2, which is equal to n whole multiplied by 6 into n square plus 9 into n plus 3 plus 3 into n minus 1 whole divided by 2. This is further equal to n whole multiplied by 6 into n square plus 12 into n plus 2 whole divided by 2. Taking out 2 common from the numerator, this is further equal to n whole multiplied by 2 into 3n square plus 6n plus 1 whole divided by 2. On solving it, this is equal to n whole multiplied by 3 into n square plus 6 into n plus 1 . Therefore, required sum of the given series, that is 2 into 5 plus 5 into 8 plus 8 into 11 plus so on up to n terms, that is Sn is equal to n whole multiplied by 3 into n square plus 6 into n plus 1 , which is the required solution. Let us see another example. Find the sum of n terms of the series 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus so on . Now let us see its solution. First of all, let an denotes the nth term, then an is equal to 1 plus 2 plus 3 plus so on up to n. Now, as we know that sum of first n natural numbers is equal to n into n plus 1 whole divided by 2. So, the nth term an is further equal to n into n plus 1 whole divided by 2, which is further equal to n square plus n whole divided by 2, which is equal to 1 upon 2 into n square plus 1 upon 2 into n. So here nth term an is equal to 1 upon 2 into n square plus 1 upon 2 into n. So, sum of first n terms of the given series, that is Sn, which is equal to summation of An, will be equal to summation of 1 upon 2 into n square plus 1 upon 2 into n, which is further equal to summation of 1 upon 2 into n square plus summation of 1 upon 2 into n, which is equal to 1 upon 2 into summation of n square plus 1 upon 2 into summation of n. Now, because we know that summation of n square is equal to n into n plus 1 into 2n plus 1 whole divided by 6, and summation of n is equal to n into n plus 1 whole divided by 2. So, the sum of first n terms of the given series is equal to 1 upon 2 whole multiplied by n into n plus 1 into 2n plus 1 whole divided by 6 plus 1 upon 2 whole multiplied by n into n plus 1 whole divided by 2, which is further equal to n into n plus 1 into 2n plus 1 whole divided by 12 plus n into n plus 1 whole divided by 4. Taking out n into n plus 1 whole divided by 4 common, this is further equal to n into n plus 1 whole divided by 4 whole multiplied by 2 into n plus 1 whole divided by 3 plus 1. This is further equal to n into n plus 1 whole divided by 4 whole multiplied by 2 into n plus 1 plus 3 whole divided by 3, which is equal to n into n plus 1 whole divided by 4 whole multiplied by 2 into n plus 4 whole divided by 3, which is equal to n into n plus 1 whole divided by 4 whole multiplied by 2 into n plus 2 whole divided by 3. On solving, it is further equal to n into n plus 1 into n plus 2 whole divided by 6. Therefore, required sum of first n terms of the given series 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus so on, that is Sn is equal to n into n plus 1 into n plus 2 whole divided by 6, which is the required solution.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ sum of first n natural numbers and its applications ਅਤੇ sum of squares of first n natural numbers and its applications ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਹਨਾਂ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Let us see another example. Find the sum of n terms of the series whose nth term is n square plus 3 raised to the power n. Now let us see its solution. Let an denotes the nth term, then an is equal to n square plus 3 raised to the power n. Then sum of first n terms, that is Sn, which is equal to summation of an, will be equal to summation of n square plus 3 raised to the power n. Which is equal to summation of n square plus summation of 3 raised to the power n, which can also be written as summation of n square plus 3 raised to the power 1 plus 3 raised to the power 2 plus 3 raised to the power 3 plus so on up to 3 raised to the power n. Clearly, this series is a GP series. Here, first term, that is A, is equal to 3 raised to the power 1, which is equal to 3, and common ratio R, which is equal to 3 raised to the power 2 upon 3 raised to the power 1, will be equal to 3 raised to the power 2 minus 1, which is equal to 3. Also, as we know that sum of n terms of a geometric progression, that is GP, is equal to A whole multiplied by R raised to the power n minus 1 whole divided by R minus 1, where common ratio R is greater than 1 and A is the first term of the GP. Also, because we know that summation of n square is equal to n into n plus 1 into 2n plus 1 whole divided by 6. So, the sum of n terms of the series, that is Sn, is equal to n into n plus 1 into 2n plus 1 whole divided by 6 plus 3 whole multiplied by 3 raised to the power n minus 1 whole divided by 3 minus 1, which is further equal to n into n plus 1 into 2n plus 1 whole divided by 6 plus 3 whole multiplied by 3 raised to the power n minus 1 whole divided by 2. Taking 6 as LCM, the sum of n terms of the series, that is Sn, is further equal to n into n plus 1 into 2n plus 1 plus 9 whole multiplied by 3 raised to the power n minus 1 whole divided by 6. Therefore, required sum Sn is equal to n into n plus 1 into 2n plus 1 plus 9 whole multiplied by 3 raised to the power n minus 1 whole divided by 6 which is the required solution.
In this episode, you have learned that sum of first n natural numbers, that is summation n, is equal to n into n plus 1 whole divided by 2. Sum of squares of first n natural numbers, that is summation n square, is equal to n into n plus 1 into 2n plus 1 whole divided by 6. ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਸਮ ਆਫ ਫਰਸਟ ਐਂਡ ਨੈਚੁਰਲ ਨੰਬਰਸ ਐਂਡ ਇਟਸ ਐਪਲੀਕੇਸ਼ਨਸ ਅਤੇ ਸਮ ਆਫ ਸਕੁਅਰਸ ਆਫ ਫਰਸਟ ਐਂਡ ਨੈਚੁਰਲ ਨੰਬਰਸ ਐਂਡ ਇਟਸ ਐਪਲੀਕੇਸ਼ਨਸ ਬਾਰੇ ਪੜ੍ਹਿਆ ਹੈ। ਮੈਂ ਉਮੀਦ ਕਰਦੀ ਹਾਂ ਕਿ ਤੁਹਾਨੂੰ ਇਹ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ। ਧੰਨਵਾਦ।